crazy sounding restaurant, 'cause they're gonna try and get behind you. Don't you let them do it. You know what I'm talking about? You hear me talking? You hear me talking? It's pretty scary, baby. It's so revolting. It's pretty scary to me. It's so revolting. It's pretty scary to me. It's so revolting. It's pretty scary to me. It's so revolting. Take a stop out of the country. And you turn around. Take a look at what you are. And it's amazing. Take a good look. You're no big deal. You're so petty. It's a laugh. Take a step outside the planet. And turn around and around. And take a look at what you are. It's pretty scary.
All right, so today we're going to continue on object-oriented programming, in particular polymorphism, and then we'll finish it up probably early next week with the solid principles, and then go on to SQL before the break, certainly before the break gets here, but how much we cover before the break and then after the break, I don't know yet. Polymorphism, again, reminder that polymorphism, it stands for having many forms. And in the context of code, that means that you can write one piece of code, one variable, one method, one class that can apply to multiple different types of variables. For example, in C, if you're coming from a C background, there's only one sorting algorithm. There's only one sorting function called qsort. And it can sort integers, doubles, strings. It can sort bank accounts, right? In Python, likewise, you only have one sorting algorithm, either sorted, which changes the actual list that you call it on. Otherwise, sorted gives you a brand new sorted version of that list. And in Java, however, we have strong polymorphism. Neither one of these languages has proper polymorphism. Instead, in Java, we use explicit parameterization to achieve this. We say that there's a list of integers, and when I sort that, it will expect a list of integers, and if it's not, it doesn't even compile. If you do something like this in Python, then it becomes a runtime error, right, if you start mixing types. In C, it becomes a segmentation fault if you do this wrong. Right? Before we get to that demonstration, though, let's talk about the other types of polymorphism that we've seen so far, right, implicitly or explicitly. With subtype polymorphism, you can always treat a subclass as a superclass. Again, for example, you can treat a robin, let's go ahead and put it in code here, robin as a bird, right? So that you can put robins and ostriches and any kind of bird, you can put that into a list of birds and then do something with it. That doesn't require any specific knowledge about it being a particular type of bird. We saw this in the first demonstration that we put together, right? When I created 2 savings accounts and 2 annuity accounts here, right? I started out with 2 different lists. One list for savings accounts and one list for annuity accounts. All I was doing was printing them out. Everything has a print method. Everything has a toString method. And I was getting their value. Everything has a getValue method. I didn't need to keep them in separate lists. What I did is I used subtype polymorphism to treat these accounts, savings account as an account and annuity accounts as an account, right, as their parent type, so that I could put it into a list and just deal with them all in one list and one list only. That's the power of subtype polymorphism, that if you don't need a specific behavior, right, if you don't need specific or specialized behavior, you can treat a bunch of different types as one single type, right, the superclass. And that's polymorph, right? Many forms, you can treat it as one form so that you can simplify your code. Right? And we'll take another deeper look at this and how this works later on when we do a full demonstration. Right? Otherwise, another one that you've seen is method overloading. Now, this is not overriding. When you have a superclass and a subclass, and you change the behavior in the subclass, that's overriding. That's why we've got that override, right, annotation there, right? Override, I'm changing what the toString method does. That could also be put over here in the get value because I'm changing the abstract method inherited from the superclass, and I'm changing it down here. You did that in your lab this last week when you had net pay, gross pay, or whatever, right? Different types of employees had different rules applied to their paychecks, right? And so you were overriding those methods. Method overloading is something a little bit different. So those are coming from a C background. How did you compute the absolute value from the math library? Do you remember? Those coming from a Python background will at least name me one method that does this. Absolute value, abs, right? Right? And I'll put this into code here. For C, it's going to be abs, which only applies to what? Integers. What if you wanted the absolute value of a floating point number? It was fabs, right? Also, there's labs, and what else? Labs, right? Et cetera, et cetera, et cetera. Why? Because C does not have method or function overloading, right? When you create a function, you can you can only use that one name for that one function. So therefore, if you want to apply it to different types, again, polymorphism, what you need to do is you need to create yet another function with a different name, fabs, another function with a different name, labs, et cetera, et cetera, et cetera. Right? By the way, Python doesn't have function overloading either, right? Python does not have function overloading, right? Instead, parameters are optional. Right? You have one function called foo. That function has, say, 3 parameters. You can call that function on just one parameter and get one behavior. You can call that function on another 2 parameters and get a different behavior, right? Parameters are optional, and you can define default values, right? That's how you write functions in Python. If you want different behavior, but otherwise, there's only one function named abs, right? There's only one function named myAwesomeFunction, right? Once you've used that function and once you've defined that function, that's it. If you want to define a different but similar function, you need to provide another name, right? Or you need to do some magic with the parameters. But object-oriented programming languages are different. OOP languages, say Java, support function overloading. Right? You can define multiple versions of a function with the same name, as long as either the number, that we call this arity, or type of parameters are different. So let's take a look at what that looks like over here in Java with that absolute value function. I've got this set up for later. Let's go ahead and take a look at math.abs. Oops. Let me go ahead and create a variable first. Int x is equal to -42. I want to go ahead and compute the absolute value of x. I'm not going to print it out or anything, so I won't capture it into a variable. Let's take a look at the math library and look at that function. That function is called abs, abs. What type does it take? An integer, right? Because that's what I gave it, an integer over here. What if I had instead a double? Y is equal to -3.5. And I wanted math.abs of y. You would not be able to do this in C, right? Because you've already used a different type. Actually, what would happen in C? Truncation. It would end up becoming like -3, and then the absolute value of that would be 3, and that's not what you want, right? Let's go ahead and take a look at what Java does. Hey, there's another function called abs. What does it take? A double. In fact, if you look at the rest of this class here, there's another abs that takes a float. There is another abs, where is it, that takes a long, right? So we don't have abs, fabs, and labs, or labs, right? We just have one abs, but 4 functions with the same name. How does a compiler know which one you meant to call, right? They're all called the same, right? Joe, Joe, and Joe, right? Which one am I referring to, right? That one over there, why? How are you able to figure that out as a compiler? I'm looking at the call on line 29 here. It looks at x. It looks at the type of x. Oh, it's an integer. Therefore, you meant to call the one that takes an integer. Here you go. I'll dispatch it over there. Same story over here. You meant to call abs. Which abs did you mean to call? Okay, I'm looking at that you gave me one variable, and that variable type is a double. Therefore, you meant to call the one that takes a double. Right? Compilers are dumb, but they're able to deduce this, right? Because we wrote them to do so. Right? That's called static dispatch. At compile time, right, a compiler is able to figure out which version to invoke by looking at what you passed to it, right? The number or a type of variable. Again, this is known as static dispatch. Right? Why static? Static means compile time. Not like a static class or a static member variable in Java. That's the same word, different context, different meaning. Right? So static in this case means at compile time. The opposite of that would be dynamic at runtime. Right? So static means compile time, and then dispatch is what? Well, what is a dispatch? Right? You call in, you need a taxi, or you need a police officer at 123 A Street. Right? They dispatch somebody to go to that location. Right? So what is the compiler doing? It's saying, all right, you need to call this function. Well, that's the function that you're actually wanting to call. I'll dispatch it over there. And it's done at compile time, not at runtime. Because the compilers are dumb, but they're at least able to figure that much out. We have something very similar called operator overloading in some languages. Right? So consider in Java. What if I did the following? What if I had a string plus a string? Right? That plus symbol, how would you interpret that plus symbol in this case? Means concatenation. Right? What about string, or let's go simpler here, int plus int? What would that mean? It would mean addition. In other words, we've got the same operator, that plus symbol there, applied to two different types of situations, polymorphic, and it has a different meaning in that context. Here's a good question. String plus int. What does that mean? What's going to happen when you try to have a string, hello, plus 42? It means convert the string, or convert the int to a string and concatenate, right? This is how you concatenate stuff all over the place in convert, excuse me. This is how you concatenate stuff all over in Java. All right, so those coming from, say, a Python background, I'm going to ask you the same questions. How would you interpret string plus string? Concatenation, right? How would you interpret integer plus integer? Addition, right? Those are straightforward. Nobody is going to confuse those two. But Pythoners, let's go with this. String plus int. And here, there's no capital S. I should be going lowercase s because they refer to strings as lowercase s in Python. There we go. Right? How would you interpret, Pythoners, what does that mean? Means what? Error, right? You can't do that. Right? Instead, what do you have to do? Instead, you use str of the integer, and int is not a keyword, but str is a function, and then plus the string. Right? So in other words, you have to, it's on you to explicitly convert that integer over into a string. Right? Otherwise, it won't work. You cannot mix those types in Python. I could name you at least 3 other languages where these behaviors are completely different. PHP is just the opposite of Java. Instead of converting the integer to a string, it will try to convert the string into an integer and then cross your fingers and hope that it works. JavaScript, likewise. C, good question here. If you had a string in C, what would it look like? We don't have strings in C. Instead, we have char stars plus char stars. Those are pointers. Those are memory addresses. And so what does this mean? It's nonsense, right? Why? Because you are adding 2 memory addresses. Right? It'll work. It'll compile. It'll give you something. Probably a segmentation fault when you actually try to access that memory that doesn't belong to you. Right? So this is why it gets really, really hairy. Right? Operator overloading is when an operator, right, say, for example, plus. What's another operator? Minus, multiplication, right, et cetera, all those things. Minus, plus, multiplication, division, et cetera. But there are other operators, like there's the star operator in Python. You have that. It's the unpacking operator. An operator overloading is when an operator has more than one meaning. Oh, etc is not an operator. Right, there we go, etc. Has more than one meaning in different contexts. Different contexts. There we go. Languages that support this, languages use this very sparingly. Why? Because there are multiple acceptable interpretations depending on the context. Let's look at another context here. In any language, what would a list plus a list mean? What's one reasonable interpretation? I'm not even saying that any languages support this. Does Python support this? It would be gross and icky if you did use something like this, so I imagine it doesn't. I do have some Python up here for later. We can try to test it out. All right? A is equal to 1, 2, 3. B is equal to 4, 5, 6. C is equal to A plus B. Right? And then let's pretty print C. Anybody want to guess and get it right and get a gold star? Right? Oh, okay. What's that interpretation there? That's what first reasonable interpretation would mean. Appending. Right? You append the second list to the end of the first list, and now you've got a brand new list. What's another reasonable interpretation? Those of you coming from a calculus background, vectors, think vectors. What would it look like? Vector addition, component-wise addition. Right? Giving you a new vector. 3 things, the first 2 get added, the second 2 get added, the third 2 get added. Right? And that's perfectly reasonable, component-wise, excuse me. What's another interpretation that you could have? Right? Union, intersection, etc. Right? There are lots of things that you could interpret that as. Is it absolutely clear? And from the lack of a response from the Pythoners, I don't think it's clear either, even to Pythoners. Right? So why support something like that? You probably shouldn't unless it's absolutely clear. Strings, integers, those are so built in and ingrained into a language that those are probably okay to do that. Those coming from a C background, right? You probably really appreciated this, seeing this on day one. Thank God. I do not have to worry about null terminating characters anymore. I don't have to worry about making enough memory to support a string. I don't have to worry about calling a function to do any of this crap. I can just use plus. Right? There, the argument is that it is so convenient, it is worthwhile. And nobody is going to misinterpret this. The argument down here kind of gets a little bit more dicey. And it gets even worse when you consider other possibilities. Duration plus duration. Now, if I said something like 1 hour plus 30 minutes, that's 90 minutes total. That makes sense. But what happens when I start applying this to just anything? Time plus time. What is 3 o'clock p.m. plus 4 a.m.? Does that make any sense? No. It doesn't even make sense to answer that question, right? Some programming, in fact only one that I know of, programming languages allow you to override any and all operators. Right? For example, C++. That's the only one I actually really know. You can redefine plus to mean minus. You can redefine plus on duration to mean that time plus that time, giving you a time in the future. Right? You can do anything you want. Does that sound like a good idea? Probably not, right? At the end of the day, you have to write a function that defines what the override or overload means anyway. So if you're writing a function anyway, why don't you just give that function a nice name, right? For example, what if I had a function that said a.append b? Right? Is anybody going to confuse that as long as they understand what the definition of append is? Nobody's going to confuse that. Right? If you had duration plus duration, add time together, right? Duration A, add duration B. Nobody is going to confuse that word add. But operators, depending on the context, can have completely ambiguous meaning. Right? That's why in programming languages like, say, Java, it doesn't allow you to do this. It doesn't allow you to do custom overloads like this. Only C++, in my mind, allows you to do this. In fact, you kind of have to do this kind of stuff in C++. I forget what it's called, but or the acronym for it. But basically, when you define your own class, you're going to end up having to overload the equals method, the assignment operator, in order to make it a shallow copy versus a deep copy. At some point, you're going to have to write a function to define what that means. You might as well have just written that function and give it a nice name, and then let people call that function instead of relying on that built-in operator. Right? So again, it's not a good idea, but you should be aware that it's out there. Now let's talk about the most powerful, and at least in my opinion, type of polymorphism. And it's unfortunate that a lot of languages don't have it, but we do have parameterized polymorphism. Right? So in Java, you can create a parameterized class, variable, or method. Now to demonstrate that, what I want to do is I want to come over here, close all this stuff out, and go back to my pure demo over here and get rid of this. We live in 2023 right now. We live in an excellent Java world that has this stuff. People that say 20 years ago, in fact 21 years ago, that lived in 2002 and previous Java, they didn't live in a world like this, right? So we're gonna take a look at today's world, right? The nice world to live in, and then we're going to go ahead and take a time machine back 20 years and see what kind of a world they lived in, and see how horrible it was, right? So we've got a list of numbers here. I want to go ahead and sort it. Well, to sort it, I can of course go collections.sort numbers, and then print it out, system.out.println numbers. And you'll see that it's sorted in the natural ordering, in ascending order. Right? But that's not what I want to do. I want to sort these in descending order. So do you remember how we do this? We have to define our own, what? Go ahead. Our own comparator. There we go. Comparator, integer. So yeah, you could go ahead and save some lines of code and just simply reverse it. That's not what I want to do here, though, right? So cmp int is equal to new comparator for integers, and then this comparator. There we go. Spell it right. Add these unimplemented methods. We've got this compare method that takes two integers, 01 and 02, and I'm simply going to say return 01.compare2 02. And then I'm going to reverse those. Actually, I won't even do that. I just want to reverse this. It returns something negative if they're in order, positive if they're out of order, and 0 if they're equal. So, there, negative. Now let's go ahead and pass this comparator into the collections.sort method. 9874321. Awesome. Awesome world to live in, because we have a list of integers, we have a comparator for integers. If I said instead that this was a comparator for, say, doubles, the compiler is going to catch this and say, no way, you cannot do this. Right? You have to if you have a list of of integers, you have to have a comparator for integers. Right? Now, let's hop into our time machine here and go back 21 years. where they did not have parameterized polymorphism. This thing, this Langle-Wrangle, that's a parameterization. I am saying this is a list of integers. 20 years ago, they didn't have that. 20 years ago, they had what are called raw types. What is it a list of? It's a list of anything you want it to be. Right? Unfortunately, this comparator is also a list, comparator for anything that you want it to be. And anything in Java is an object, a generic thing. Well, what is that thing? I have no idea. Right? So how do we even go about comparing it? Right? Well, if this were a comparator for integers, I could force them to become integers. Integer A is equal to integer of 01. Those of you coming from a C background, does this look really familiar? In C, what do you have to do? You have to create a comparator function. Hey, that's what a comparator is right there. Right? And then what do you have to do? You're given const void pointers, generic things. There's no way that you can compare those. So what do you have to do? I have to force this thing to become an integer. I have to force this thing to become an integer just to compare them. Return a negative A dot compare to B. Right? And now it will work just as before. But now let's go ahead and throw a wrench into the situation. Did the compiler complain? The compiler wouldn't have complained 20 years ago. Let's predict what's going to happen here, though. Do we have a list of integers anymore? Nope. Well, we still have a list of numbers, so crossing my fingers here, maybe it'll work. Right? What happens when we come into this compare method here, and we try to force that 4.5 to become an integer? Is it going to work? In C, it would. What would happen to the 4.5? It'd become 4, right? And you would be out of order, right? Because 4.5 is the same thing as 4.4, which is the same thing as 4.9. Any order that you want, right? In Java, what do you think happens? It says, wait a second, you can't take that and force it to become an integer. It's going to be what? A class cast exception. Hopefully, I can make this, drive the point home here and really make it obvious that this is wrong. Right? Can you force hello to become an integer? Definitely not. Same thing here. You can't do that. So, living 20 years ago meant this. You used raw types. Pythoners. Let's go ahead and get rid of this. Right. Ignore that for now. We'll come back to it. Right, as we move along here. Now I've got a 1, 7, 3, 4, 2. How do I go about sorting foo here? Well, if you want to sort it in reverse order, right, then you define a lambda, and then you negate x, right? So that'll end up being, okay, well, I'm going to sort 1, 7, 3, 4, and 2, but I'm going to negate them all so that I have it in descending order. And you'll see that it, well, here I already ran it once. Right? 7, 4, 3, 2, 1. Right? Great. Let's throw a wrench into the mix. 7.5. Will this work in Python? Yeah, why? Because does Python really make a difference between integers and doubles? No, right? Will this work in Python? Hello? Yeah, sure. Question mark there. What's going to happen here? It's going to take hello and try to negate it. Can you negate a string in Python? Nope. Bad operand. Okay, fine. That's not how you should reverse anyway in Python. How should you reverse? Reverse or reversed is equal to true. I think that this is it, right? Let me go ahead and take this back to 7 and make sure that it's reversed. Oh, no, reversed. Is it reversed or reversed? Maybe a lowercase r. We'll get it at least once here. So it must be reverse. I try to, hey, there. Fourth time is a charm, right? So reverse is equal to true. And now I've got 7, 4, 5, 3, 2, 1, or whatever it is. Right? So are all of our problems solved over here in Python? Because Python's an awesome language? No. Let's throw that wrench back into the mix. What's going to happen still? I'm not negating it, so it's not an invalid operand. What? Come on. Oops, come on. There we go. Type error. Less than is not supported between instances of string and integer. In other words, when it goes to compare hello and 1 to find out which one should be first, it literally has code there that says, is hello less than, strictly less than 1? Right? This is not going to work. Right? But am I prevented from doing this in Python? I could print this out as long as I don't sort it. Right? It's perfectly happy having a mixed type like that. Just like Java 20 years ago was perfectly happy having a mixed type like this. Why? Because you just treat everything as something, as an object, as a thing. Right? Does that sound like a great way to go about doing things long term? No. Why? Because things become unpredictable. Right? If you're allowed to do something like this at compile time, right, then every error will manifest itself as runtime. The reason that you have to do that over here in Python is because it's not a compiled language. It's an interpreted language, right? The reason that you have to do that in C is because C does not have is not object-oriented programming, right? It does not have parameterization like this. You can design what's called a static analysis tool. You can design a static analysis tool to go through and do the same thing that a compiler would in a parameterized language like Java, and say, whoa, 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 that doesn't look right. Right? You are having a mixed type here, and then later on you try to sort. Warning, before you even run this script, it's probably not going to work. Go back and fix it. Right? But it's not part of the language itself. Right? Did I have something else down here? Oh, here's a way. Here is my attempt at trying to do this. Here we go. Let's go ahead and get rid of all this stuff first. There we go. 17342. I print out bar. I sort bar. It won't work, of course, because of mixed types here. But then here's my attempt at sorting it. So read me that lambda, Pythoners. Oh, you saw Python styles like this, right? Yes, no, lambdas, no? Okay, all right. Then I'll walk you through it. How do you use this key? A lambda is a fancy word for an anonymous function. If I create a function in Python, def my awesome function, right? And then I do something, print, I'm awesome. Awesome. Right? There we go. There's my awesome function, right? That function has a name. What is it called? My awesome function. Oops, sorry. I'm not doing it the Pythonic way. There we go. That's Python, right? I'm awesome, right? The name of that function is my underscore awesome underscore function. What is the name of this function? It has no name. We call it lambda. That's what a lambda function is. Given x, right, as input, this would be like x right here, right? Given x, ord of x if type x is string else x. The way that you read that is order of if. This is not even my, actually, let's go with 0. I don't want to get into ord right now. Ord is ordinal. It gives you the ASCII text value, right? 0 if type x is string else x, right? And then let's go ahead and try to sort this now. It worked. Why? What did I do here? If the type of x is string, then use 0. In other words, it's my attempt at putting all strings first and then sort all the integers last. Otherwise, if it's not a string, then go ahead and just use x as your key. Right? This is not going to work if, for example, what? If I have negative values here. Right? Now, well, it depends on what you want, I guess. You want all the negative values, then all the strings, then all the non-zero values. It'll work, right? But why would you want to do that? I have no idea. Right? There is no easy way of doing this. Right? The Pythonic way, which would be the easy way, would be to bring in a library called functools and make your class or make something comparable. Then go to old school C and make a comparator function, and then give that function to this functools library, and it takes care of it for you. Right? So in other words, you're doing things the C way 50 years ago still, because you cannot afford parameterized polymorphism. let's go all the way back up here. Undo, undo, undo. Right, there we go. Now, we live in the 2023 world. In fact, we've been living in this world for 21 years in Java. Right? We have proper parameterizations. Many languages support this. C++ has supported this for a very long time with STL, this standard template library. C# started out supporting this immediately almost, right? We have a parameterized collection here so that if it's something different, like a string, right? It knows, no, you can't do that. That's an array, that's a list of integers. You can't assign it to a list of strings, right? We have very, very predictable typing here, right? I like living in this world because the more you can take away to chance, the more that you can take away at runtime, the more predictable your code is. Right? I like to describe computer science, computer engineering, software engineering, whatever you want to call it. None of those, computer science is not a science. When we say science, we mean natural science, studying the natural world. Computer engineering, software engineering, it's not engineering, right? It's something different, right? Because computers are something different. Think about a bridge builder, like a civil engineer building a bridge. They design it perfectly. They build it perfectly, except for one bolt. How likely is it that that bridge is going to collapse? No. You write 1,000,000 lines of code, but you forget one character. How likely is it that your code is going to run correctly? 100%. If it's a compiler error, 100% it doesn't even compile, right? If it's just a simple error, like say the nefarious go to fail bug, right? Where somebody forgot one semicolon. And for the better part of, I think, 2 decades, right? There was a fatal security error in Apple. It was literally 1 colon, I believe. That basically, the omission of that 1 colon caused all of these security checks to fail and immediately go to fail, right? In other words, yeah, security's fine here, right? This bug was in Apple's SSL library for, I think, for 20 years or so, or maybe 10, at least 10 years. And anybody that could see it could, exploit it, right? Because instead of one colon, they had a semicolon instead. Right? So it wasn't even the omission of one character. Right? So yes, in software engineering, computer science, whatever you want to call it, that one bolt matters. Right? The more you can take away from chance, right, the better, right? Because it matters. Parameterized polymorphism is awesome. Right? Now, I want to show you the power of doing your own parameterized polymorphism. To do that, I'm going to go ahead and steal the code that I had from before. Let's go ahead and go back to account demo here. There we go. I'm going to go ahead and recreate all this stuff over here in demo. There we go. There. I just want these savings accounts and this stuff. I'm going to go ahead and get rid of this code because I want to make a function that adds up all of the values of all my assets and tell me what the result is. Right? So let's go ahead and try doing that as a first attempt here. Okay, let's see. Yep, there we go. So I'm going to go ahead and create a public static double, right? Sum, right? Sum values. There we go. SUM sum values. List of, I don't know what yet, right? Of, say, accounts. Right? We'll go ahead and say that this is, say, savings accounts for now, okay? And I'm going to have pretty much the same code that I had before. Double total is equal to 0.0. And then I'm going to iterate over all those accounts, get the total, sum up the total values, and then return that value. So return total. I'm going to go ahead and go into an enhanced for loop here, savings S in accounts. There we go. And I will go ahead and say total plus equals S dot get value. There we go. There. Great. I could do this with annuity, right? But now they're not savings accounts anymore, right? So, but before we do that, let's come down here and actually try to do this with the savings accounts, okay? I want a list of savings accounts, right? my savings accounts is equal to new array list. There we go. And I will go ahead and add to it my savings accounts. Copy. Dot add S1. Dot add S2. Oops. There we go. And then I'll call my function up here that I've built. My savings double total is equal to savings accounts of my savings accounts. There we go. And print it out. System.out.println total. There we go. Some really quick code here to just sum up my $100 savings account and my $200 savings account. I've got $300. Right? Time to go buy 150 lottery tickets, right? No, don't do that. Right? Take it to a casino and bet on black instead. Don't do that either. All right, so what is my total? 300. Except that I started out with a list, right? What if I didn't care about the order? What if I said that, oh, okay, well, I'll just go ahead and go with a set of savings accounts, hash set. There we go. That broke my code. Why? What is that function good for? Lists. All right. Copy, paste, a set of savings accounts. Now it all compiles and works. Right? Copy pasta, copy pasta, copy pasta. Should I be doing something like that? No. Right? What was the difference? Was there any appreciable difference? All I did was change a list to a set. Because of function overloading, right, I can use the same name, some values, right? And so I could have a list and a array list, and it'll still work, right? But should I have two functions that do exactly the same thing? Exactly. Right? Probably not. So what is a list and what is a set? Do we remember from my little diagram that I showed you? Let's pull it up. Here's the truncated version of that. There we go. Collection, set, list. Think about subtype polymorphism. If you have a set and you have a list and you have zero difference between those, you're just going to iterate over them and sum up these values. What could you treat it like? Covariantly. Right? Here's that other picture. Bird diagram. No. Where is my bird guy? Contravariance. There we go. Right. Treating a robin as a bird so that you don't have, because you don't care that it's a robin and that it flies. You just want it to do bird things, right? Other than flying. Flying is not necessarily a bird thing, right? Ostriches walk, right? So you don't want to treat it like a set and do set things. You don't necessarily want to treat it like a list to do list things. You want to treat it like a collection and do collection things, like simply iterating over it and being done with it. Collection. Get rid of that. There. Now I have to import that, sorry. Import. Now it works down below regardless of what my type of collection is. Still works, right? One function to rule both of these situations. In fact, to rule all of these situations. Doesn't matter if you have a hash set, tree set, array list, linked list, or the myriad of other options that you have in the programming language. You have solved this summing value problem for the rest of your life, right? At least as far as collections of savings accounts go. So let's go back and create a list of not savings accounts, but annuity accounts. There we go. And this will be an array list. And my annuity accounts dot add A1, my annuity accounts dot add A2, and I want a total of those. So total is equal to some values of not my savings accounts, but my annuity accounts. There we go. And then I'll print out that total. Oops. Annuity. There. Okay. It's not going to compile. Why? Because we live in the nice 2023 world of strong parameterized polymorphism. It's saying this is a collection of savings accounts. You are trying to apply it to a collection, a list is a collection, of annuity accounts. Is that going to work? No. Annuity accounts are not savings accounts. That's called an invariance. You cannot force a robin to become an ostrich, right? No matter how hard you try. Right? All right, so again, my solution is to cut and paste annuity. There we go. And change the code down here to annuity. There we go. Good strategy. Anytime you find yourself cutting, pasting, cutting, pasting, cutting, pasting, you're probably doing something wrong. And by the way, we did see, I don't know if anybody saw the thread, but somebody pointed out that there was a bug in 2 of the test cases. I don't know who they're from, and I'm not going to dig around to find out who they were, but in order to make larger data sets, they simply just cut and pasted stuff. Copy, pasted, copied, pasted, copy, pasted. And so when they did that, they failed to change the unique code IDs. And so we had, say, 3 pieces of equipment, all with the same code IDs. Well, guess what? Only one of them made it into the output because, okay, ID, well, they're all the same, so we'll just take that one, right? So don't do that, right? Don't copy paste it. Not just with code, but with, just basic data, right? There's going to be better ways of doing that stuff. Right? So in this case, though, yeah. What's wrong? So function overloading fails me at this point because it's the actual complaint here is that there's a erasure of methods sum values is the same as another method. It can't, we've confused the compiler too much here. When I call these values on, when I call these functions on lines 55 and 61, it doesn't really know which one you mean. Because we've taken away too much information. So now we have to live in the C or Python world where we have to give these different names. Some values for savings, some values for annuity. Now, do you want to go back to the world of C where you have to do abs, fabs, labs, labs? Rename, copy, paste, copy, paste, copy, paste? I don't. Right? So is there a better solution? Why do I have 2 lists? Why do I have 2 sets when I can, again, apply covariance and treat them both as birds, or in this case, accounts? Let me go ahead and do that. Account. Get rid of for savings. Treat them all as accounts. There we go. And be done with it. Guess what? Everything works. Oh, sorry. Save this. What's wrong? Some values, my annuity accounts. It should be accounts. Okay, yep. So, sorry, I should have ended on that last one. This looks a lot better, but it still has a problem, right? And let me read you the, hopefully it'll be clear. It's not applicable for the arguments set savings. This gets into the second part that I was going to talk about with parameterizations of what are called named parameterizations. Right? So, sorry to leave you on a cliffhanger for Friday, but we're going to solve this problem on Monday by introducing another concept. Basically, what we're going to use is a generic variable. So just as a preview here, let me go ahead and get rid of that. Right? And undo so that it actually compiles. There we go. Undo. There we go. There's my variable x. I'll assign it a value of 42. What type is x? An integer. Double y, 3.5. What type is y? It's a double. TZ. And don't worry about it. Can I put it there? Nope. Can I put it here? Yep. Well, okay, it's still not going to compile. But eventually it will compile. What type is Z? It's type T. In other words, the type itself is a variable, right? Sometimes it can be an integer, sometimes it can be a double, sometimes it can be a string. In other words, you can polymorphically create a variable that doesn't necessarily have a fixed type. Instead, later on, when you use that variable, then the type is inferred. So what type is it? Yes. All right. What is that subreddit? Inclusive or? Right? where you ask, if somebody just asks questions. Okay, we don't want to do that. Anyway, getting myself into trouble by just doing random Google searches. No, there's a subreddit called Inclusivore, which is different from Exclusivore, right? So the Inclusivore is, do you want to do A or do you want to do B? And you answer it with, yes, inclusive, both of them. I want to do that, right? So check, if you're brave enough, go ahead and check out that subreddit. There are a bunch of examples of it, right, in real life.